All right, moving on to part C of question 2. We're told that we have a new function called h, which is given by h of x equals kx times 1 minus x, with x values from 0 to 1. For each k greater than 0, the region enclosed by the graphs of h and g is the base of a solid with square cross-sections perpendicular to the x-axis. Okay, so we're dealing with the function g like we had before, and now we're dealing with the function h instead of f. So I'm just going to note that here, just to take stock of what functions we're dealing with. And we're told there's a value of k for which the volume of this solid is equal to 15. Write but don't solve an equation involving an integral expression that could be used to find the value of k. All right, so we're told that this area between h of x and g of x is the base of a solid. We're told that perpendicular to the x-axis, we have square cross-sections, which are cross-sections of the shape of which the area is a base. And simply all we have to do is figure out the area of one of these cross-sections. So here's our plan. Figure out area, and then integrate to find volume. So figuring out the area of one of these squares, we need to figure out the length of one of the sides. And what is that length? Well, that length is simply h of x minus g of x. That's just the distance between the h of x curve and the g of x curve. And so in order to find the area, we simply square that length. So we figured out that the area of one of the square cross sections equals h of x minus g of x squared. And now to find the volume, we're simply going to integrate h of x minus g of x squared. We're basically just taking the area of this square cross section and adding it up a bunch of times in order to find the volume of our shape. We'll do that from x values 0 to 1 because we're integrating with respect to x. And we simply plug in the values for h of x, which are kx 1 minus x, for g of x, which is 3 times x minus 1 times square root of x. And then we're asked to write but not solve an equation involving an integral expression that could be used to find the value of k. So to find the value of k, we could just set this equal to 15, because this expression would equal 15 if our volume was 15. So that's our answer, that's our expression. We don't have to solve it, and we're done.